All right, ladies and gentlemen, Jason Bucca here from MrBucca.net, and today we're going to go over Think Java Chapter 1. If you don't know what Think Java is, it is a free resource. It's a really great resource, and if you want a copy of it, one way to get it is going to MrBucca.net, clicking on Java Programming, and then if you just scroll on down to the How to Install Clips and the JDK at Home, you'll see the Think Java text link there. Now, the website may change by the time you get to it, but I will always keep the Think Java text under the How to Install Eclipse and the JDK at Home. The book looks like this, and it was written by Alan Downing and Chris Mayfield. They did a great job, and the publishers are amazing for allowing this resource to be so easily accessible by people who are trying to learn how to program. So I highly recommend you grab this copy and start using it on your own journey. Even though I'm going to cover a lot of it, it definitely is not a reason not to read the book, because there's going to be some fine details that maybe they say differently, or that I just miss or I don't cover, that will benefit you greatly. So make sure you download a copy as well and make good use of it. This video is going to be unlike most of mine. It's going to be more talk-based. That's because I'm just trying to cover the material. And then I will finish up Chapter 1 in the video after this that will have a little bit more hands-on, and I'll go back to some of the keywords, the term words, and I'll show you it in a computer programming sense as well. But really, this first chapter isn't about programming. It's more about computer science that leads into computer programming. Now, I'm going to assume that you have the JDK and the Eclipse already installed on your computer. If you don't, please go back to MrBucca.net and that section that I just showed you on the Java Programming 1 site. And under that, How to Install at Home, you'll see 3 videos. They're really quick. I think they're like 3 minutes long each, maybe. And they'll get you up and running with all free resources that are ad-free, spyware-free, all that stuff. There's no garbage to them. Again, one of the reasons why I go use Java is because it is so well supported. It's an open source program, and there's a lot of ways to really get involved in the programming without having to spend a bunch of money. All right, so let's get over the chapter here. Problem solving. They go ahead and they explain it, but really that's what programming and computer science is all about. So you think of a problem and you ask yourself, how can I solve it using a computer or an electronic device? How can I create this program that makes this solvable, and not only solvable, but solvable all the time correctly as well as efficiently as possible, right? So this is definitely an area in which computer scientists must excel. And if you struggle with problem solving, like you think back to math and how you struggle with that, perhaps, or hopefully you excel. But if you don't, it doesn't mean you won't do well in programming. It just means you're going to need to work on your problem solving skill. So you haven't reached that level yet, but you will. Right? What is computer science? As the book reads, it's the science of algorithms, right? And an algorithm is a sequence of steps that specify how to solve a problem. This lovely lady on the bottom right corner is Ada Lovelace. She is credited as the first person who's written basically written something that is ready, a program that's ready to run on a computer. Now, she was about 100 years before the first computer, but still she gets that credit. And as a matter of fact, there is an object-oriented program named Ada, named in honor of her. So algorithms, things like Ada Lovelace worked on, are all in our lives. And this video here does a great job of really kind of making what might seem a complex conversation into something that's really easy to understand and actually pretty interesting. I mean, even things from bubble sort to merge sort seem real easy when this narrator discusses it. So I highly recommend, as you progress, at some point, go back to this video and watch it. It's on a popular streaming site. All right, so what is programming? Well, programming is writing the sequence of instructions that specify how to perform a computation. Now, that could be a math problem. That could be how to make a peanut butter and jelly sandwich. That could be a lot of different things. But writing those little sequences, that algorithm, so that it all makes sense and that it performs all the time very well, very robust programming, that's programming, right? So here's some term words. Now you can obviously read them, so I'm not going to read the exact words here for you. I'll explain them in my way, and then of course, read how they explain them as well. And hopefully one or both gives you a better understanding. So input is anything that you say or do to the electronic device. So from clicking a mouse to maybe it takes your speech, maybe it takes some video from you to read your face, maybe you're punching in a PIN number, whatever, that's input, whatever information you give to the electronic device. Output is the opposite. So whatever that device gives back to you, maybe you do something wrong and it goes, it gives you a sound, that's output. Maybe it flashes a picture to you, maybe it spits out money because it's an ATM machine, so that's output. Math, well, we use math a lot in our programming. Even sometimes we don't even realize we're using math. If you're not great at math, don't let that turn you off. I know I struggled a lot with math when I was in high school, and it wasn't until I got into programming that math mattered to me and it made sense to me, and I was able to do a lot more thanks to programming. Decisions, all of our programming usually involves some sort of decision-making process. If this happens, do that. Else, if that happens, do that instead. Think about any of your popular video games. If you shoot a character in some game, but you just kind of graze his shoulder, probably not going to cause as much damage, right? But if you hit him in a sensitive spot, well, maybe that damage is greatly increased, or maybe it's an automatic, a kill of that character or whatever, right? So you might have decisions. And repetition, use repetition a lot in our programs. An ATM machine might count money, so it has to count repeatedly. We create robots that's, maybe weld spots in a car, and it has to do 50 welds, so it'll read all 50 of those welds and just do something that's very repetitious. Programming. So really when we program, we take what's a big problem and we break it into all these small pieces. It's like a puzzle, kind of doing it in reverse, right? So we tear this puzzle apart, and then we get all these little pieces that mean something and have their own little functions, and then we slowly but surely put it back together so that it functions properly and well each time. I think one of the biggest mistakes that young programmers make is they will take a look at this problem and they'll try to solve all of it, as opposed to just taking a little piece and then trying to solve just a little piece of it, making sure that works, and then moving to the next one. I'll keep reiterating that throughout the future videos. Programming languages, there's lots of them. All right, I cover Java specifically because it's openware, so you can easily get it. It's open source. It's free. It's supported in many ways, like the Think Java text that we're going to be using as the backbone of a lot of these conversations as we start. There's lots of videos, lots of resources out there, and it's used in the AP Computer Science test. So if you're a high school kid, these things should help you out, and there's a lot of employment in it as well. So it's not that it's better or worse than any other language, because there's a lot of great languages out there. And the nice thing is, if you learn how to use Java, chances are you're going to be able to very easily migrate to lots of other open source programs. All right. So Java is a high-level language, which means it's friendly to us. We can read it and understand it relatively easy, and then we basically turn that into a low-level language. And a low-level language isn't so easy to understand. It's machine language. If you've ever watched like The Matrix and you see all those ones and zeros and stuff like that flying throughout the air, that's your machine language. So a lot harder to understand. I mean, just imagine if you had to write 8 1s and 0s sequences in order to create one letter, and you had to write a whole book like that. That would take you forever. So that's actually one of the cons to using machine level language. You could, but it would probably take you a very long time. High-level languages are easier to visually for us to read. It takes less time to create them, and it creates less time to debug them or to figure out what's wrong with them in the high-level languages. High-level languages are also portable, so I can run it on a Windows machine for Java, say, and then I can run it on an Apple, I can run it on a Unix, Linux machine. I can run it on several other electronic devices, and chances are it's going to run just fine. I don't need to change anything. But on a low-level program, like using machine-level language, that's not going to happen. It will not run on another device. Sometimes, even with it in the same genre, I might take it from a Windows PC of one brand manufacturer and move to another brand manufacturer, and no dice. It's just not going to work. So that's one of the advantages of using a high-level language instead of a low-level language. As we look onto high-level languages, obviously we have to break those down for each machine, so there's lots of different ways that happens. In Java, we use something called the Java Virtual Machine. I'm not going to get too deep into that just yet, but there are a couple different ways that we can break down those high-level languages to be understood by the machine. One is an interpreter, and the other is a compiler. So an interpreter kind of reads the language as it executes, which is kind of why I put this picture up here on the right. There's this blindfolded runner here, right? So that's kind of what that program's doing. It's running and translating at the same time. Now, if there's some kind of wall in front of there, some kind of issue, we're going to smack right into it. We're not going to have much of a chance. So, pros and cons to that. And then there's a compiler, and the compiler reads it first, and then we would find out if there's any errors before it fully compiles, and we'd go back and fix it before we actually execute it. So pros and cons to that, but we will always, in these series, compile our code and then run it once it's successfully compiled. Once it does compile, it turns into object code, or what we might call an executable. Object code in Java is a class file, so a .class file, and we can turn that into an exe so that you can just click on it and it runs on any machine, or, well, in theory, any electronic device. Once a program is compiled, you can execute it repeatedly, so we don't have to recompile it or anything like that. And so for that reason, once they're compiled, they generally run a little bit faster than interpreted programs. So Java is both of these things. It's compiled and interpreted. Like I said, though, we're going to be compiling ours. I'm not going to get into any interpreted kind of runs. And instead of translating the program directly into machine language, what we do with Java is we turn it into bytecode, and that bytecode is read by the Java Virtual Machine, and then it's just easier and faster to interpret. But it's also very portable, so again, we can move it from one device to another. So the Java Virtual Machine, the interpreter, we know it as the JVM if we're talking about PCs or our larger devices, but on an Android device, it's called a Dalvik Virtual Machine. Don't really need to know too much of that at a beginning level, but it's information for you. All right, so I imagine right now your brain's probably a little bit tired, and that was a lot of information in a relatively quick amount of time if you compare it to actually reading the chapter. Please make sure you do. Our next video will get further into chapter 1, but we'll actually be programming. So if you don't have the Eclipse and the JVM installed, please make sure you go back to MrBuku.net, go to the Java Programming 1 site, use those 3 videos to install the Eclipse and the JDK. Make sure you're doing them step by step, and we'll be up and ready to program next time. Thanks.